lesson 6.4, we're going to talk about sampling distribution of sample proportions. So an example of a sample proportion would be, imagine if I wanted to know how many students at Cleveland High School look at TikTok daily. It's probably a pretty high percentage. All right, I could ask every single person, right, and find out what that actual percentage is, right? The percentage of people that watch TikTok at least once a day or look at TikTok at least once a day. Or I could take a bunch of samples and look at the proportion of people on average in that sample that watch or that look at TikTok every day. Um, and then I could look at those sample proportions. It would be much more efficient. So um, those proportions, right, is this the proportion that you get from those samples is the sampling distribution of your sample proportion. So here is the official definition of a sampling distribution of the sample proportion. All right, so we're going to be calculating the mean and standard deviation of the sampling distribution of a sample proportion. It is a lot like, at least, well, sorry, there are a lot of similarities in this and what we did with binomial calculations. We'll see that especially when we look for normality. But here, that mu sub p hat, this thing right here, what you're looking for when you're looking for p is right here in the problem. There will be a percentage, or in the question. So you're going to have to calculate, or you're going to be asked for the mean of your sampling distribution. And then you're going to be asked for the standard deviation. That mean is actually going to be the percentage given your question. And then over here, remember that n is your sample size. And that p, well, we've already talked about what p is. So we'll calculate that to get the standard deviation of our sampling distribution of p hat. So eventually we're going to use this mean and standard deviation to find a probability that some proportion is above or below or between two values. But before we can do that, we have got to check our large counts condition, right? So if the distribution passes these two tests, right, that the sample size times our proportion is greater than or equal to 10, or that our sample size is times 1 minus our proportion is greater than or equal to 10, then we can say that the distribution is approximately normal. Once it has met these conditions, we can use some sort of normal probability calculator in order to calculate the probabilities that I was talking about before, right? The probability that the probability of getting a value, probability of getting above some value, below some value, or between two values. And we'll use that probability calculator that I've given you guys. And this is the same condition that needs to be checked for your binomial probability as well. All right, so let's get right into an example here. What's that spot on my potato chip? A nasty potato, that's what that is. Okay. A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer finds convincing evidence that more than 8% of the potatoes in the entire shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment. Suppose that the proportion of blemished potatoes in the entire shipment is p 0.08, right? And that matches with this. Remember I said p is going to be the percentage given in there in your question. And there it is. P is 0.08. They're going to randomly select a sample of 500 potatoes for inspection. So the first thing we're going to need to do is calculate the mean and standard deviation of the sampling distribution of p hat and interpret the standard deviation. Now remember, we've been given this information that n is 500 and that p is 0.808. Oof, golly. All right. So for one, right, the mean of our sampling distribution of our sample proportion is equal to p, which in this case was given to us. It's 0.08. The standard deviation of the sampling distribution of the sample proportion is the square root of p times 1 minus p divided by n, which in this case is 0.08 times 1 minus 0.08, all divided by 500. And if you put that in your handy dandy calculator, you get approximately 0.0124. Okay, 12. It's just 0.2. So all right, and the second question, oh, whoops, we didn't finish it. We need to interpret the standard deviation. So to interpret that standard deviation, I would say that on average, the proportion of blemished potatoes it's going to vary from the mean, which is 8%, and it's going to vary by about 1%, right? That 0.012. The next thing we're being asked to do is justify that the sampling distribution of p hat is approximately normal. So in other words, what we're being asked for is to show that n times p is greater than or equal to 10 and that n times 1 minus p is greater than or equal to 10. So we've said that n is 500, p is 0.08. So 400. Sorry, my bad, 40. And then we've got, we'll plug back in over here in this n times 1 minus p. And this one is 460. And so that checks out as well. Since both of those conditions are satisfied, we can assume that the sampling distribution of p hat is approximately normal. All right, the last thing we're being asked to do is to calculate the probability that at least 11% of the potatoes in the sample are blemished. Okay, at least 11% are blemished. So it says at least. That means that's the minimum value, right? 0.11. So what we're looking for is the probability that x is greater than 0.11, right? At least 0.11. We're going to use that normal probability calculator. And what we're going to be looking for is if the probability that a value is above 0.11 in that normal probability calculator. Let's go ahead and get that thing out and see what we've got. So there it is. We've already calculated our mean the mean is, or we didn't calculate it, it was basically given in the problem. It's 0.8. Put a 0 in there so you can see that 0.8. Our standard deviation we calculated was 0.012. And we're looking for the probability that a value is above 0.11. We'll hit enter. Something weird just happened. Oops, that's why. Our probability, our mean was not 0.8, but 0.08. There we go. And that's much better. So we get a probability of 0.0062. So it's fairly unlikely for that to occur. Six two or 6.8, golly. 6.2. And that is it. That's the lesson. So for your assignment, you're going to have to do those three things. You're going to have to calculate the mean and standard deviation. Then you're going to have to show that the distribution is approximately normal, and then calculate a probability using this normal probability calculator. And I'll make sure to include a link in the assignment on Google Classroom. So thanks for listening. I hope you have a great day. And if you're not, I hope it gets better.